Alright, hopefully it works. I'm just gonna make sure. Is it doing it? Give me a second. Okay, hopefully it's doing it. Okay guys, so I'm gonna go ahead and go over this I'm gonna go over a section on this Precalculus live stream. So this is for those that did request for me to do more live streams. So here you go. Hopefully y'all can hear me well enough. I'm gonna just go ahead and do this. So hold on. Give me a second, guys. I'm just gonna do a few things here. Hold on. Before we get started on this topic. Now, I just want to go over this topic. It's titled functions and function relations, or functions and function notation, excuse me. So we're basically gonna do what represents a function, all the good stuff. We're gonna go over the terminology, everything. And I'm also going to go over kind of how to some practice problems afterwards, so that y'all can y'all can see how to do certain problems. Give me 1 second, guys. I'm just gonna go ahead and do the following. Hold on. Okay, and I'm gonna keep my, because I don't usually use the to see it on the side. More I go ahead and look at my phone to see what whoever comments or whoever does comment on the live stream. So give me 1 second, everybody. I'm just gonna go over here, and we're gonna just go ahead and put all messages like this, and we're gonna go ahead and get started. So here, let me try to see here. And by the way, guys, I did put a link to this book, so that way, if y'all do have questions or something, or if y'all want to take a look at it, y'all can do so. Alright, so, let's go ahead and get started. So, over here, and actually, I'm gonna just do, hold on, guys, I'm sorry. I'm gonna just do following. Now, these are the learning objectives for this section. So we're gonna go ahead and just read it. In this section, you will determine whether a relation represents a function, find the value of a function, determine whether a function is one-to-one, and use the vertical line test to identify functions, as well as graph the functions listed in the library of functions. What they mean by that is like parent functions. I'm not really going to go over every single part. Of course, I'm going to do the main, like, the terminology, and then we will go ahead and do, like, the, we're going to do, more, like, the, you know, the problems. So we're just going to skip to this. So it says a relation is a set of ordered pairs. The set of first components of each ordered pair is called the domain, and the set of the second components of each ordered pair is called a range. So in other words, the x value is the domain, the y value is the range. We usually call, and I'm just going to quickly, you know, go over here. I'm going to try to just, hold on guys, I'm going to do another page. Hopefully it loads correctly. I don't know why it's doing this right now. I don't know why it's doing that, but let me, hold on guys, I'm going to try to open it again. Okay. So, oops. There's something on it. Okay, so, in other words, like I'm just gonna go ahead and just define what input output means. So input is the x value. It's usually what we call the x terms. In other words, the domain. And then there's also the range. We call it the output. And we call those the y terms, or whatever the list of y terms there are in a function. So that's what that means. I'm just quickly defining this stuff. And also, we also call the x term. So in other words, we also call this stuff so we call this the independent variable. A lot of this is like review from college algebra, if you think about it, or algebra 1, algebra 2 if you're in high school. The y term is known as the dependent variable. So so yeah, we just want to make sure we understand that stuff. We call this the x, y, etc. So, we're gonna go ahead and just, you know, so that's basically what this means. And a function is a relation meaning like a list of numbers, right? So like in the domain, there's a list of numbers 1, 2, 3, 4, 5, and it's paired with a range, which is, you know, 2, 4, 6, 8, 10, right? That is what that all means, okay? I'm just going to briefly explain this stuff. And they go over this kind of thing where it's like, okay, you have a list, you know, you have an input, and I'm going to go ahead and define this myself. So I'm going to just do like maybe 2 bubbles here, kind of just something like this, right? We're going to say this is x, this is y, and we have a list of numbers here. So really, this is going to be the following, and we're going to have the following. It would be like, let me pretend, let's say we have a list of numbers 1, 2, 3, and we have 2, 4, 6. Now, when it is okay for a function to have, let's say, for example, I'm just going to do a very simple example. The 1 can be paired to 2, the 2 can be paired to 4, and the 3 can be paired to 6. This represents the following ordered pairs. So the first one is 1, 2. Second one is 2, 4. And the third one is 3, 6. So we know that if we kind of put that on kind of like a graph or something, right? We can list that as like do 2, 4, and then I'll do this as 6 and then 8 like that. And I'll do 1, 2, 3 here. So 1, 2, 3. Very simple stuff. For now, I'm just kind of showing you guys how to kind of plot coordinates and stuff like that. So here, we're gonna go ahead and just plot them. So 1, 2 is right here. Oops, 1, 2 is right here. So that's 1, 2. 2, 4 is right here. 2, 4. And then 3, 6 is right here. So we're just gonna kind of, so we can kind of see that, it kind of forms a straight line. And you can also just do the origin, and we can do something like this, right? And we can see that there's a relation between, the x and y axis, the x terms and y terms. There's a relation, right? Now, so that is, graphically how that would go. And this is okay for it to happen. So we know that this would be a function. This is a function, right? All of them are relations, but this would be a function because every x is only paired to one y value. So every x So this is a function because every x is paired to only one y value. We want to make sure that we understand that every x can only have one y value. Now, even if, let's say, for example, I have, I don't know, 1, 2, 3, and let's do kind of the same idea here. 2, 4, 6, right? And let's say, for example, there's something that's going on that goes like this. This is paired to this, but this is also paired to this. And we know that this is paired to this. I don't know. Let's see. I guess I can't put it on more than one. But we can kind of, let's do the same kind of thing here. I'm going to do another little graph here. 2, 4, 6, 8. And then 1, 2, 3. Just do this like this, right? So, we can clearly see that 1, 2, 3, and yeah, like this, right? Now, Now, on the, so for this one, we want to go ahead and do the following. So we're going to put, so let's say, for example, we want to do so that I know that the following coordinates are true, right? We know that we have a 1 paired to 2, so we're going to have, oops, sorry. We're going to have, we know that 1 is paired to 2, so this part here is 1, 2, so let's write that down. 1, 2, so that's that first part there. We also know that there's a 2 paired to 2, so you can kind of see this going on here. So the 2 here, even though I know it's kind of, you know, but we can see that there's a 2 paired to 2 again, so 2, 2. We can see that very clearly. And then we also know that there's a 3 paired to 6, so we're just gonna put this here like that. And it doesn't matter like what kind of, you know, we can clearly see if we do some like line, if we draw a straight line, we can clearly see that every x is only paired to 1 y. So I mean, clearly it is a function, so we can see that. So 1, 2 is right here. 2, 2 is over here. And then 3, 6 would be like right here. And this is okay because, you know, you can have repeating y terms, just no repeating x terms. So for a function, it is okay to have repeating y terms, but no repeating x terms, okay? Again, to know whether it is a function, we do not want repeating x terms. I really emphasize that, guys, because if there are repeating x terms, it is not a function. It will not be a function if that happens. So no repeating x terms. Okay, guys, that is how we know whether it is a function. You always want to look at your x terms. If there is an x term that is repeated, then it will not be a function. It is a relation, though. All of these are relations. Okay. So, so now let's go ahead and, look at the following. And so now, we're gonna just, so yeah, no repeating x terms, okay? So we can clearly see that this is a function. This relation can be a function, right? You know, there's no, and graphically, the way that this looks, we're also gonna look at this graphically. It does follow the vertical line test, and I'm gonna go over that in a few minutes. But this is an example of it is okay to have repeating y terms, no repeating x terms, however. I'll show y'all graphically what I mean when it's not a function. So like if I have let's do 2, 1, 2, 2, and then 3, 4, and 4, 5, something like that. And let me redraw this. So we're gonna do this like this: 5, 4, 3, 2, 1. And might as well just do 0, 0 as well. So let me just grab this and just put 0, 0 here. So these are my coordinates, right? And obviously we know that there's a problem here. This is a repeating x term. Sorry if my handwriting is really crappy. Hold on, guys. Repeating x term. Okay. So clearly here we're gonna do the following. So it is gonna be so clearly this is not a function, and I will show you guys why it is not a function. Okay. So I'm gonna just do 1, 2, 3, 4, 5. And then I will also do I'll also do the following, and it's going to be 2. So I'm going to do from 1 to 4. I'll just do from 1 to 4. Okay. Okay. Now, like I said, it doesn't matter if it starts at the origin or if it doesn't matter. We just want to know if it's a function or not. So okay, so we have the points 2, 0, 0. So let's do 0, 0 right here. It's at the origin. And then we also have the following, and it's gonna be 2 comma 1, so 2 comma 1 right here, and then what else, 3 comma 3, so it'll be like right here, and then 4 comma 4. I'm just gonna like, and then 4 comma 4 is like right here. Now, I mean, I'm gonna just go ahead and I'll take these off because I'm gonna trace it anyways. But I'm gonna do it in green so that you guys can see what I'm talking about. And actually, hold on. I'm sorry. It was also 2 comma 2. I forgot about that. So if y'all, I can highlight each of them if it helps. So 0, 0, I'm just gonna like, I don't know. If y'all need help like actually plotting them, let me know, but I really doubt. I'm sure everybody should know how to plot them by this point. Oh, sweet Jesus. Let me just Oh god. Okay, well, I'll just do it this way. Something like that. Okay. Now, there's a problem here. This cannot happen. Now, this is different from the idea of inverse functions. We're not going to do those yet. I'm going to just go ahead and... This is only for a function, right? This is what we call the vertical line test. And I'm going to go over that in a minute. So, that is really what this is talking about. Obviously, in these first three examples, we can clearly see that, you know, the first one can be a function because even though there's, you know, this part here, this first part here, we can clearly see that it's okay because, you know, it's only one, you know, x paired to one, you know, one x paired to every y in the every output. One input is paired to only one, you know, only one output. And it's okay for part B to be a function because they're only paired to one output, right? But this one is not a function because we can't have one input paired to more than one output. This cannot happen because, like I said, it will not be a function, okay? And that is the idea of vertical line test, but we're gonna go over some examples, and I'm gonna just go ahead and skip these. Like, well, for this first part, it's okay for this to be, so like a function. We know that the inputs for this one, the inputs are this. There's no repeated input. There is a repeated output for the jelly donut and the chocolate donut, but this is okay because, like I said, it follows the form of this first part. It follows this, you know, so that's okay. So if we show the solution, oops, we know that there's only, oh, and actually, I'm sorry. So the price is a function of the output, of the input. So basically, in other words, when I have a relation, I just want to go over this briefly. Let's say 2, 3, 4, 6, 5, 2, whatever. We can clearly see that there are no repeated x values, so we can say that y is a function of x. Sometimes they will say that y is equal to f of x. Now this is in function notation. This right here is what we call function notation. Okay, guys, so that is another part that I want to define here. It is called function notation, and we read this as f of x. Okay, sometimes people say f parentheses x, but really it's f of x. Okay, So that is how we read that. Sometimes they use, a lot of the time they use like h of x. Sometimes they'll say h of x. This is the same thing. This is h of x, okay? Sometimes they'll refer to a function f. This is the same as f of x, you know. So don't think that this is like multiplication or anything like that, because it's not. It's a notation. It's function notation. Now, it says, the first one says, is price a function of the item? Well, the price is the output. The output is always a function of the input if the input has no repeated x values. Give me a second, guys. Sorry. Okay. So, this one is going to be, and we're gonna just go in here and you know, we obviously can tell that the first one is true, but this one says, so part B says, is the item a function of the price? X cannot be a function of Y. So whenever you have this going on, so like, let's pretend we have X and Y. We have like 1, 2, 2, 4, 3, 6, whatever. X is not a function of Y. In other words, the input cannot be a function of the output. Okay, guys, we really want to make sure we understand that. Only the output can be a function of the input, but not input a function of the output. So I know that sounds confusing, but I really want to make sure we understand that. Let's move on to, so this is the idea of what, you know, h of a, f of a, h is a function of a, f is a function of h, etc., right? Now we want to look at interpreting a function in function notation. So I'm just gonna, let me go ahead and do snip and sketch here so that we can look at this. Or web capture. This example. Oops, what in the world? It's not what I wanted to do. Oh Lord. Sorry guys, hold on. Go over here. Web capture. Just gonna grab. Oops. Oh my god. Okay. If it doesn't do it right, I'm just gonna like do. Okay. Now, I want to go over this example because, well, yeah, it's very important. So, all right, so we're going to go ahead and do this example. So here we have a function n equals f of y represents the number of police officers n in a town in year y. What does f of 2005 equal 300 represent? Now, let's do the year as y. So I know that I had said y equals f of x, but in this case, n is f of y. And y, we know, is the number of years. Or I'm sorry, the year, the specific year, right? And n is the number of officers. Oops. I'm so sorry for my handwriting, guys. So we know that n is the number of officers, y is the specific year. So we want to know what does f of 2005 equal 300 represent? Well, I know again that f of y is equal to n, right? I know that n in this case is 300. And I know that y is the year, so I know that y is the year, just right here. So that means that in 2005, because year is y, which is equal to 2005, and n is the number of police officers, so n is equal to 300. So in other words, in 2005, there were 300 police officers. And in a town. So this is what it represents, guys. We have to be careful with how this is read. You have to really try to read it very carefully. So again, I would of course label what n represents, what each letter represents, because that's going to help a lot. And just really think about how you form it. So if we look at the solution, the statement f of 2005 equals 300 tells us that in the year 2005 there were 300 police officers in the town. Okay, if y'all hear a plane in the background, I'm so sorry. I live right by an airport, so I do apologize. Of course there's using tables, right? It is kind of the same thing, representing functions using tables. Sometimes they'll use a specific symbol or letter, so like we can sometimes they'll say y of x. It really depends on the topic. So if we're talking about, like, I don't know, it really applies to more like the application problems. So for example, this part here will be like d of m, or f of m, d equals f of m, so on and so forth. Sometimes they'll just say d of m instead of f of m. It is the same thing. Days is a function of the month, so on and so forth. of course, we went over tables. We just know that if there are repeating x values, it is not a function. Obviously, this first table right here, the 2, 5, 8, represents a function because there are no repeated x values. You always want to look at your x values to make sure whether or not it is a function. Let's look at the next one. Table 6, or table 7 in this case, is negative 304. You see how there's repeated y values? That is okay, but no repeated x values, okay guys? Do not make sure that there are no repeated x values. So table 6 is a function. Now let's look at table 7, excuse me. Let's look at table 8. So table 7 is a function. Table 6 is a function. Now let's look at table 8. Now table 8, if you look very carefully at your x values, there is a repeated x term, so this is not a function. Table 8 is not a function because the input is repeated. We can't have two outputs for one input. Okay, let's look at the solutions. So we can clearly see table 6 and table 7 define functions. In both, each input value corresponds to exactly one output value. Table 8 does not define a function because the input value of 5 corresponds to 2 different output values. And that is exactly what I had said. We cannot have 2 output values for one input value. That cannot happen. Now, in this example 6, we're going to look at actually how to evaluate functions. So we're going to look at this example, and actually I'm just going to do that same thing I did earlier. Instead of actually like oh dear God. Hold on, I'm sorry guys. It is so difficult sometimes to... Okay. Now we're gonna copy and paste it right here. Now this one, if we want to actually evaluate functions, so this is again something that we've done maybe in like, whenever we were in high school or college algebra, stuff like that. We did this most likely in college algebra, but we're doing it again just to make sure we understand, because in calculus they go over this kind of stuff, especially part D when we're doing limits, when we're doing like the derivative of a function by limit definition. So we have to make sure we know how to do this. So it says evaluate f of x equals x squared plus 3x minus 4 at part A, which is 2, part B, A, part C, A plus h, and then part D, f of A plus h minus f of A all over h. Now, we're going to go ahead and do this first part. So let's write our function, f of x equals x squared plus 3x minus 4. And so we're going to go ahead and just evaluate the following. So, I'm sorry guys, hold on. So like I was saying, this first part, we want to do it. So part A, basically evaluate f of x at x equals 2. In other words, we want to know what f of 2 is. So f of 2, again, we have our function. I'm going to rewrite it in the following way. We have f of x equals, again, we have x squared plus 3x minus 4. I'm going to put it the following way. F of x equals the quantity x squared plus 3x minus 4. This is going to be, so now we're going to put in x equals 2, I think it was. So we're going to put x equals 2, just this stuff here. So we have f of 2 equals the quantity 2 quantity squared plus 3 times 2 minus 4. Okay. So here, we're going to just go ahead and do the following. So we have, so I know that, so f of 2 is equal to, this is 4, right? Plus 6 minus 4. So we have to know how to do this, guys. Very important. This is going to be 10 minus 4, which is equal to 6. So f of 2 is 6, right? The way this is read is like, what this means is that when x equals 2, f of x equals 6. In other words, we want to go ahead and say the following, okay? We want to also say that at x equals 2, f of x equals 6. This is also read as f of 2 equals 6, or f of 2 is 6. Something similar. This is how we read it, okay? You know, that is the main idea for that. Okay? So that is how we do part A. Part B wants us to do it at f of a. So part B, we want to do f of a. So again, we're going to rewrite our function, x squared plus 3x minus 4, yeah. So then, again, I'm just going to do that same thing I did. Let me do it in blue this time. Okay. So here we're going to go ahead and do the following. We want to make it equal to a, so f of a will be the quantity a squared, plus 3a minus 4. Okay, guys? that is how we do this, okay? So at x equals a, f of a is a squared plus 3a plus minus 4, right? Now let's do f of a plus h. Now this is where a lot of students get confused. I want to go ahead and introduce the sum of two squares pattern. Or sum of a binomial squared. I'm going to say it like that. A binomial meaning that we want to, it's basically two terms being added. Sum of a binomial, it's just two terms either added or subtracted. In this case, we add it. So I'm just going to put this formula here. This is an important formula we must understand for this one. We also can use FOIL method, and I'm going to go ahead and briefly explain that. So the quantity a plus b, quantity squared, is really going to be a squared plus 2ab plus b squared. And if you guys wonder how I got that, I'm going to do it by FOIL method. So there's also FOIL method, in case y'all don't understand how to do this. So basically, if I do a plus b times a plus b, this is going to give me the following. I'm going to do a squared plus ab. So we're multiplying all of these, right? Plus, and some people say BA, but really BA equals AB. It is the same thing. This is, I always forget what this one is, commutative or associative property, one of those. So BA is AB. Oops. And then, so plus AB plus AB, you know, plus B squared. So we have a squared, and these two you can combine, plus 2ab plus b squared equals a plus b squared. So we know that that is what we get, right? Now, we're going to go ahead and do some other ones. Now let's do let's go ahead and do so now we're going to use this rule, okay guys, to do part C, which was, what was it again? I'm sorry. F of a plus h. Again, I'm gonna so part C says evaluate, really they just give us f of a plus h, but it's evaluate f of a plus h. We're gonna do it, I'm gonna do it in green. Okay. Now, again, f of x is x squared plus 3x minus 4. Was it? I'm sorry. Yeah. It was x squared plus 3x minus 4. So that's part C. We want to do f of a plus h. So we're going to do, again, we're going to just put f of x in like this, but we're going to make x equal to a plus h. So we're just going to rewrite it the way that I always like to do it this way, so that we kind of, a lot of the time in my videos, guys, I color code, because especially with calculus, it is a lot, okay? So I do it because a lot of people, like me, I'm a visual learner. I like to learn visually. Now, we're going to go ahead and do the following. So, now f of a plus h, so f of a plus h, gonna do, so we're gonna put the following in here. The quantity, I like to put the quantity, when I say parentheses, I always say the quantity. A plus h, quantity, squared, plus 3 times, or times a plus h. When I don't really do the quantities, anything, I just say a plus h, times a plus h, or parentheses a plus h. So times plus 3 times a plus h minus 4. Now this is why it's important to know the sum of two squares pattern, or the binomial squared pattern. This is going to be the following, and like I said, we're going to follow this rule. I know that a plus h squared is a squared plus 2ah plus h squared. Like I said, if you don't know how to do that, please do FOIL method or study the theorem, because it's very important for these. So we have a squared plus 2ah plus h squared. So that is this first part here, guys. Okay, now we're going to do distributive property, plus 3h plus 3a, I'm sorry, plus 3a plus 3h minus 4. So, obviously there's nothing we can combine. You have to look very carefully and see if you can combine anything. Obviously, we cannot combine anything in here. So f of a plus h is really just going to be a squared plus 2ah plus h squared plus 3a plus 3h minus 4. You don't have to do anything with this. This is it. Do not try to like factor or anything like that. It's not needed. Okay, guys? Alright, so now let's go ahead and do, so now let's go ahead and do the next one. So that was part C. And now part D, this is where it really gets difficult. So part D is where, you know, this is kind of why we did parts A through C. D wants us to do f of a plus h minus f of a. I'll do all over h. I'm gonna take the colors off once I do the final answer. Because we already did f of a plus h as well as f of a, we're just gonna plug it in. In other words, I'm gonna rewrite it, f of a plus h, and I'll do highlighter so that y'all can see what I'm doing. This is why color coding is so important for me. I'm a bit OCD about it. Now, Now here, we're gonna just do, so, like I said, f of a plus h, and let me rewrite it. It was a squared plus 2ah plus h squared plus 3a plus 3h minus 4. And like I said, there is nothing to combine here. This is what's going to go in for this. Oops. Let me just kind of... Now, when it comes to the minus sign, you want to be careful, okay? You really want to be careful with the minus sign. We're going to put f of a, and we did f of a, did we do f of a? Yeah, we did it. F of a was a squared plus 3a minus 4. So I'm going to write that down. This is what will go in for this. To know how to do this, guys, it is so important for calculus. This is like one of the first things you do in calculus. So I really want to emphasize that, and I really want to make sure we understand how to do that. Okay. Let's plug it in. So really, this is going to be the following. A squared plus 2ah plus h squared plus 3a plus 3h minus 4. That is that first part of f of a plus h. Now, when you do the minus, put either brackets or parentheses because we are going to distribute that minus all the way through f of a. So we're going to put minus the quantity, a squared plus 3a minus 4. This is so important, guys. We're going to put this in here. A lot of people forget that. Please do not forget anytime you're subtracting anything like this, put parentheses or brackets, because 99.9% of the time you're going to have to distribute that all over h. Oh god, it's not what I wanted to do. I didn't even know you could do that with the highlighter. Now, let's just rewrite it over here. So this stuff, just rewrite it here. So we had, again, a squared. I know I keep writing over and over, guys, but like I said, I just want to make sure we have, I want to explain it as much as I can. All over h. So, so here's where it gets interesting. We're going to distribute this negative. So we're going to have a squared plus 2ah plus h squared plus 3a plus 3h minus 4. We're going to put the minus symbol like this. It's going to distribute minus a squared minus 3a plus 4. So you want to be careful. Make sure you distribute. Distribute negative symbol / sign. You always want to make sure you do that when you're subtracting. All over h. Now let's look at our like terms. We obviously, you want to look at for common like terms or common, things that are common here. We have an a squared, a negative a squared. We have a negative 3a, 3a. We have a 3h, or actually, I'm sorry. we have a -4 and a 4. Those are all going to cancel out. So this cancels out with this cancels out with this cancels out with this. You have to really have good eyes for these guys. Really, really read it carefully. If of course me, I can do this pretty fast, but for somebody who's barely starting off, do it slowly, because it's a lot. Do not try to speed up if you keep making mistakes, like silly mistakes, slow it down. That is one of the most top tips for math classes, like for any math class you're taking. If you're struggling with the topic, slow it down. Do not try to do it too fast if you do not know what you're doing, or if you make silly mistakes. Because even me, when I do calculus, I make very silly algebra mistakes. Everybody makes mistakes. Even the smartest people make mistakes. Okay, so now we want to look at what can we take out / factor out. If you look very carefully, there is an h in common with all of these. We're going to factor that out, but you want to be careful. Take it out. When I do h, when I take out the h, if I think about it, h times 2a is 2ah. That's because if I divide by h, well, 2a is equal to 2a, right? So I'm going to say that this is h times the quantity 2a. Oops. Plus, and I'm going to look at the next term. The next term is h squared. So I'm going to say h times something gives me h squared. What is it? It's going to be h. So I'm going to put that right here. And you can always check it back using distributive property. Anytime you factor, you can check back to make sure you did it correctly, to make sure it gives you the same thing that's on the top using distributive property. I know I don't have to go over all of this, guys, but this is like review of algebra. We're really going to have to know this for calculus. And then times the 3. Again, you're just taking out the h, okay? And all over h. So all in all, we get the following. And if you look at it, right? The h it's out, right? If you look at it, there's this going on and this going on. Remember that property? A times b over a is just b, because this cancels out. So therefore, this will cancel out, and we're going to end up with 2a plus h minus plus 3, excuse me. That is our final answer, guys. That is what we get for the final answer for this problem. Hold on, guys, I'm sorry. So, let's look at the solution for this, obviously. If I go all the way to the top, this first part, we got f of 2 was 6, right? Obviously, I got the same thing. You put in 2 for x, 2 squared. It doesn't matter here if it has parentheses, but I always put parentheses because for negatives, if I put parentheses negative something squared, close parentheses like that, it's positive. So we have to understand that. Part B, we can just do distributive property, FOIL method, all that good stuff. I got the same thing here. Sí. Oh, más tarde. Sorry, guys. we're almost done with this section. Once I finish this section, I'm gonna end the stream. I just have to get a haircut. But anyways, let's move on. Okay. Now the last part is very difficult, right? It is a lot, okay? We ended up with 2a plus h plus 3, which was exactly what we ended up with. It's literally what I did, but I just explained it a little better. Now, there is the idea of evaluating functions. Given the function h of p is p squared plus 2p, evaluate h of 4. So, okay, this is the same idea that we did in the previous one, but now we're going to put, h of 4. So h of 4, again, we're just going to do the quantity 4, quantity squared plus 2 times 4, like this. Okay. So again, we're just evaluating, this is 16 plus 8, just going to be equal to, I'm going to say 24. So that just means when p equals 4, h of p is 24. When the input is 4, the output is 24. Now this one, it's a radical. We're just gonna go ahead and do it. G of m is equal to the square root of m minus 4. And evaluate g of 5. So g of 5, we're just going to put in 5 for m, so the square root of 5 minus 4. So this is going to go in for this here. And then this gives me g of 5 is equal to the square root of 1. Obviously, the square root of 1 is 1. So g of 5 is 1. That is all that is, guys. Now, there is a difference between evaluating and then solving. So solving functions is another thing. So there's a difference between, again, if I say g of a is equal to when equals g of a, which equals when x equals a, g of x is what, right? Or g of a is what, right? But when we have g of a is, or g of x equals some constant c, where c is any real number, when g of x equals c, what is x? So that's what that means, guys. So this one, try it number 5. If I look at the h of p is p squared plus 2p. So let's go ahead and do it again. This means when, oh, and actually, I'm sorry, h of p is equal to 3. So when h of p equals 3, p is equal to what? So we're going to put this in for h of p. So we're going to say that 3 equals p squared plus 2p. Now, if you guys remember, you need to subtract the 3. Otherwise, it's going to be wrong. You can also do it by completing the square, but I don't recommend that right now. So we're going to subtract 3. Get p squared plus 2p minus 3 equals 0. We want two numbers that multiply to -3 and add to 2. I will go over more of that when we get to quadratic equations. Right now we're just going to go ahead and I'm just going to go ahead and factor it. This is going to be p plus 3 times p minus 1 equals 0. So we're going to have p plus 3 equals 0. So this is zero product property. P plus 3 equals 0. We subtract 3 on both sides. P is equal to -3. And then p minus 1 equals 0. We add 1 to both sides. P is equal to 1. That is all this is, guys. We need to understand how to do zero products property. We need to understand how to solve quadratic equations to do this. Otherwise, we can do it by graphically as well. So it's kind of the same idea we did here. We have to know how to do this. So yeah, some of this involves actually factoring. We can clearly see that when p is equal to 3, and h of p is equal to 3, excuse me, we can clearly see that graphically here on figure 6. Okay. Now we're going to look at the triad number. We're gonna try to do triad number 5. This one is a radical function, so I'm just gonna go ahead and write it. We have g of m equals square root of m minus 4, and we want to solve whenever g of m is equal to 2. So g of m is equal to the square root of m minus 4. And we want to solve it again when m is equal to when g of m is equal to 2. So again, I'm going to put this in for this. So I'm going to say that 2 equals m square root of m minus 4. Now, if you remember from college algebra, whatever, we can clearly see that this, to get rid of the square root, we need to square both sides here. So m minus 4 is equal to 4. This undoes the square root, or cancels out that square root. So basically it's gonna, it's gonna cancel it out. So then to solve for m, we're gonna add 4 to both sides. And this is gonna give us m equals 8. If I'm going really fast, guys, this is a lot of the stuff we did in algebra. I will do a college algebra stream for those that, are pretty, forgot the word, but, like, you don't remember a lot of it. So, okay, so now we want to find the equation of a function. We want to say 2n plus 6p equals 12. So we have 2n plus 6p is equal to 12. And it says express as a function p equals f of n. if possible. What this means, guys, is we really want to do this as a function of n. We want to do this, we want to get p equals, so if p equals f of n, then p of n equals f of n. I really want to emphasize this rule, guys. Like I said earlier, if you're doing like an exam or something, sometimes they're gonna state it this way. But you want to make sure that really p is the output. In other words, p of n is the output. If they're using the f function, the g function, whatever, the g letter, whatever you call those, it's really just, you can just put it as p of n, or f. If they say p of n is f of n, put it as like, you know, p of n, whatever. So that, I really want to emphasize that. Now, we're going to go ahead and just do, I'm trying to think here. So, basically we need to solve for p. So, I mean, obviously we're going to solve for p. P of n is f of n. You don't need this actually. We're gonna just, you put it as f of n instead. But that is true, and I really hope you guys write that down, or really make sure you understand that. So we know p is f of n, so we're really gonna say, so we have 2n plus 6p equals 12. What I'm gonna do is we want to isolate p, okay? So we're gonna go ahead and just, to do that, we need to subtract 2n. So our goal is to get p by itself. So this will cancel out. We're gonna get 6p equals 12 minus 2n. Now this is the part where we want to be careful. We're going to divide by 6, but I'm going to split it up, okay? So what I'm going to say is p is equal to 12 over 6 minus 2n over 6. There's a reason for that, because a minus b over c is really a over c minus b over c. They have the same denominator, so you can put it as one fraction, and both of the terms on top will be subtracted. I just want to make sure we understand that. Now, this obviously will be a 2, so p is 2. Minus, and 2n over 6, I just want to make sure we understand this as well. A over bx is really ax over b. The 2 over 6, however, we can reduce that. 2 over 6 can be, we can divide by 2 on top and bottom, we'll get 1/3. So really, this is going to be 2 minus n over 3, or 1n over 3 in this case. But we can also say it the following way: p is equal to 2 minus 1/3 n. We can also remember, I know this is a lot, guys, but we can also remember that b minus a is b plus negative a, which is negative a plus b. It doesn't matter how you write it. You can keep it this way, in fact. I'm not going to really show y'all how to do it by writing it where the n goes first and all that stuff. I just don't think it's convenient in this case. I'm not even going to go over this, but because I don't want to over explain it, but that is how we do this problem. Oh, and actually, so we know that P is f of n, I'm sorry, P is f of n. So f, thus, final answer will be f of n is equal to 2 minus 1/3 n. You can also say f of n is 2 minus n over 3. It doesn't matter. Either or works, whichever one you want to do. It really doesn't matter. If you like the first one better, do the first one. If you like the second one better, do the second one. But try not to put both because, yeah, I mean, I don't want to push anybody to do both. Just do whichever one makes more sense to you. Okay. Sorry, guys, hold on. So, let's look at the solution. Again, I mean, it's the same thing. 2 minus 1/3 n. It doesn't matter though. I mean, really, this is the more common type of way to do it. If your professor or your teacher takes off points because you put the n on top, to me, that's kind of stupid, but everybody is different. Now this is where example number 10 is where, like, it gets a little bit hard. So I just want to emphasize something here. When we talk about functions and function notation, we do not want the y to be squared, because if it is squared or cubed or whatever, it is not going to be a function. And actually, come to think of it, I'm sorry, if it's squared, if the y is squared or raised to the 4th or something, actually, if it is squared, I'll just say if y is squared, such as the example number 10, most likely it will not be a function, and I will show y'all why. Let me type this one. Hold on, guys. I'm sorry, hold on. I'm gonna type this, guys. Give me 1 second. Expressing the equation of a circle as a function. I do want to emphasize, guys, I am not going to go over every section in this book with live streams, because there are certain things that I just cannot do. I mean, or maybe I might, but not every example, because there are certain things that I cannot do, because I am not perfect. I don't want to do something that might be wrong, or you guys might find it difficult to understand if I try to explain it. I just want to make that disclaimer. So, I'm sorry, hold on. Does the equation... Give me a second, guys, I'm sorry. x squared plus y squared equals 1 represent a function with x as an input I'm sorry guys, and y is the output. With x as the input and y as the output. Hold on, guys. Hold on. And then what else does it say? I'm sorry. If so, express the relationship as a function of y, as a function y equals f of x. Okay. All right. Let me just go ahead and I always like to squeeze it in because I don't like to do it as I don't like it when it's very extended like that. Okay. Okay, so hold on guys. All right. Now, let's go ahead and do this. Now, our goal is to solve for y. Anytime we have problems like these, we want to solve for y. And in fact, I'm going to go over some examples. I don't know if they have other examples that... I don't think they have other ones that... I don't think so. I'm going to go over multiple examples with this topic because I don't want to, just do this one and then have you guys confused because there's many types of these. So I'm going to do some examples that are not in the book. We're going to solve for y. In other words, we want to get this by itself, the y term. To do that, obviously there are, I'm sure we've done this in algebra. We're going to subtract x squared on both sides to step 1. I'll write down the steps. Subtract x squared from both sides. So when we do that, get y squared equals 1 minus x squared. Now, number 2. Oh God. Okay. Please respond. Okay. Sorry guys, technical difficulties there. We're gonna do number 2. Take square root of both sides. Okay, this part, guys, I want to really emphasize this because this is very important. When you take the square root of a radical, or I'm sorry, of a, when you take the square root of a y term or something, if it's like y squared or whatever, you want to do the positive and negative answer. So make sure to do positive negative answer. Negative I'm sorry, guys. Give me a second. Oh, Lord have mercy. Why is it being slow? I'm sorry, guys. Let me take this out for a minute. I'm sorry. So annoying. I'm sorry, guys. Where is it? Okay. Like I said previously, I just want to make sure why is it being so slow? I'm sorry, guys. Oh my gosh. Disconnect this. If y'all hear silence, give me a minute. I'm just writing this down. Oh dear God, why now? I'm sorry, guys. Hold on. Of all times. Okay, guys. This is what I'm talking about. If n is even, you want to do positive and negative square root. Most likely, we're just going to be dealing with the exponent of 2. We're not going to be doing like to the 4th, but if it's cubed or something, I don't think you have to do square root. I mean, I don't think you have to do plus or minus. But this is, if it is odd, just do positive square root. So if n is odd, these are just extra notes I'm making. And actually, I'm sorry, not square root, but positive nth root. Nth root. Only positive nth root. Positive, right? I know that's a lot, but if we had like cubed root or something, we're just gonna do positive. So this is just an extra thing I added, okay? So in other words, when we do the square root of this is really going to be y is equal to plus or minus the square root of 1 minus x squared. There's a problem here. This cannot happen. That is because if you do the positive and negative of this, really the and I'm gonna make sure I do this correctly, but oh dear God, I think the negative, if I do if I literally do the graph here of y equals plus or minus the square root of 1 minus x squared. So I'm going to do 1, that's y is equal to the square root of 1 minus x squared. It's going to look something like, I'm going to do, this is just a rough sketch, but I'm going to try to do it. It's going to look something like this. Okay? But if I do the negative, it's going to look like this. At least I think that's how it'll be. So there is something called the vertical line test, guys. But since we're doing in terms of tables, let's say for example, I don't know, here's 0, right? Right here is 0. There's 2 points at 0. So I'm going to say that this represents 0, 1, and this represents 0, -1. Obviously, like we said, if we put that on a table, this connects to the idea of the table of values. If I put 0, 1, or 0, -1, and 0, 1, this implies that x value, oh God, I'm sorry guys, Lord have mercy, technical difficulties. So this implies that there's a problem here. These two repeated. And remember, if we look from earlier, we had said if that happens, then it cannot be a function. It will not be a function if that happens, okay? That cannot happen. So, because of this, x squared plus y squared equals 1 does not represent a function. I'm gonna state a theorem, guys. If y to the n equals f of x, where f is basically in terms of x, right? And if n is even, f of x is not a function. Okay? And if n is odd, f of x is a function. I'm sure there are examples in the book. I'm just stating that right now. For example 10, that's basically what that means. We can clearly see it has two different things going on for y, so it cannot be a function. Now this one, x minus 8y cubed, we can clearly see, and that's an example of what I'm talking about. This is okay. If I have x minus 8y cubed, we can say the following for this. So our goal again, so is x minus 8y cubed equals 0 a function? So our goal here is to get y by itself. So what I'm gonna do is first I'm gonna add 8y cubed. So step 1, add 8y cubed. Okay, guys? We want to add 8y cubed first. You can subtract x, but this is the best way to do it. So we have x equals 8y cubed. Number 2, we're going to divide 8 on both sides. So if we do that, we get x over 8, or 1/8 x equals y cubed. Okay. And then number 3, take cubed root of both sides. If I do that, I'm going to get, so I'm going to do the cubed root of both sides. I'm going to do the cubed root of 1 over the cubed root of 8. Remember that the cubed root of a over b is really the cubed root of a over the cubed root of b. That's a property, guys. I just want to make sure we understand that. So really this is going to be the cubed root of x over, and we know the cubed root of 8 is 2. So really this will be 1/2 cubed root of x. I'd like to write it this way better, but we can clearly say that y is equal to cubed root of x over 8 over 2, excuse me. So when it's, again, when n is even, when n is odd obviously, the nth root of x, n is odd, thus f of x, or y is a function of x. Or in other words, what we had originally, x minus 8y cubed equals 0 does represent a function. I know it's a lot of writing, guys, but I like to be very clear. Okay, so that is how we do that one. I'm trying to go really fast with these because I just feel like there's so much. Now, this is where I'm just gonna paste this like I was doing in the beginning. Lord have mercy. Hold on, guys. I'm sorry. Oh. Just do it like this. Copy and paste it here. If it'll let me. Come on. God, this shit is irritating. Excuse my language, guys. Okay. Now we're looking at tables, right? So this is an example of one of these. It says evaluate g of 3 and then solve g of n equals 6. So we want to understand how to do this from tables. So now we're getting to the point of tables with these. Okay, so with this one, we have evaluate g of 3. This means that when n equals 3, g of n equals what? That really is what that means. When the input is 3, what is the output? So we're going to look at when n equals 3. So obviously it is right here. What is g of n? Obviously we get that g of n, what is the output? G of n is 7. So that is part A. So g of n is 7. Okay? That is what that means. Now this part means solve g of n equals 6. So this one means when g of n equals 6, what is n? So we're going to look here for g of n equals 6. So, you know, here. So right here, this is where g of n equals 6. So here we know that if g of n is 6, n has to be equal to 4. So n equals 4. That is really what that means, guys. That is all that is saying. That we have to understand the difference between those two. A lot of people get that confused, so you have to be careful. You have to understand what each of these terms mean. Okay? And again, my OneNote is acting up. Oh my god. Okay. So obviously, if you look very carefully, g of 3 is 7. So g of 3 is 7. It's what we just did right here. I don't even know if I did. Okay. G of 3 is 7, right? That was that first part. When n equals 3, g of n is 7. In other words, g of 3 is 7. Let me write that down in black. So this first part, g of 3 is 7. And then g of n is 6. N is equal to 4 for this next part, for part B. Okay, that is how we do that one. It's really not as difficult. You just have to understand how to do it by tables. Okay. Now by a graph. Okay, guys. I'm gonna do the same thing here with just web capture. Hopefully it doesn't. Okay. Copy and paste. This saves a lot of time for me. Sorry guys, hold on. For this first part, evaluate f of 2. So we can, I'm going to do this separately here. We want to know when x equals 2, what is f of x? Now graphically, you're going to go to the x-axis. So we know that x is 2, right? We're going to go here. So when x is 2, what is this going to be? We know that that's the point 2, 1. So f of 2 is 1. That is all we have to do. Solve f of x equals 4. For this second part, f of x is 4. So we're going to look at the horizontal, right? We know that when f of x is 4, we have this, right? So we can clearly see that there's an x value right here at -1, as well as right here at 3. So f of x equals 4 at x equals -1 and x equals 3. That is how we do that part, guys. It really isn't that difficult. You just have to read this very, very carefully. I mean, it is common and it does take time, but really the goal here, the main idea is to read it very carefully and to understand what they're asking. So obviously we can say that f of 2 is 1. You know, obviously we have that there, and then we also know that when y is equal to 4, f of -1 is 4, f of 3 is 4, so x is -1 and 3, okay? Okay, we are almost done. For this stuff here, we're gonna go ahead and I'm just gonna explain this very briefly, guys. A 1-to-1 function is really an inverse function. So, in other words, let me go ahead and go over here to the next part, because the horizontal line test just determines whether there's an inverse. Obviously, we already kind of went over vertical line test. If the vertical line test crosses it more than once, it is not a function. Whereas if it does it only once, it is a function. So in this case, part A, we can see that if we draw like vertical lines here all over, it only crosses the graph once. So yes, part A is a function, because when we do vertical lines, we can clearly tell that it is a function because it only crosses it once. Part B as well, we can clearly tell that it is a function because it only goes once. But part C is a circle. We can clearly see that it is not a function because it crosses it here, 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 here. So when that happens, it is not a function. The horizontal line test is different. That just means that if there is like an inverse, okay? So I'm just going to briefly explain all of this stuff. So vertical line test, vertical line can only cross curve f of x once for it to be a function. Try to take this off. We are almost done, guys. I'm so sorry for the technical difficulties and all that stuff. So an example of this just means if we have like some kind of curve here, we can clearly see that if we draw vertical lines all over, crosses it here, 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 here. It only crosses it once, so this is a function. So it follows vertical line test, so this is a function. Vertical lines only cross once, thus curve represents a function. Now, when it doesn't represent a function, this is if I say, for example, like a circle, right? If I see that it crosses it twice like this, this is not a function. Because there's an error here. This does not follow vertical line test, therefore it is not a function. VLT, vertical line test. Vertical line crosses circle twice. Thus, not a function. Okay, guys, all of this is really just review from algebra. Oh my god, please. So that is all that means, right? I mean, and now the horizontal line test. This is a little tricky. So the horizontal line test represents when it is a one-to-one function. A one-to-one function, in other words, is an inverse function. So what this means is, this is, in other words, horizontal line test. I'm trying to go pretty fast because, like I said, I don't think this is like review. If y'all have questions over this stuff, let me know, but I'm trying to go fast because I do have something to do in a while. So like, the horizontal line test just means that it can only cross it once. So for example, I am gonna go ahead and just draw some random curve. If I do, for example, something like this, and I draw horizontal lines all over, this is an inverse function. But the thing is that I mean, honestly, it would not be a function per se. Let me actually, I'm sorry, hold on. It is one-to-one. So what I mean by this is like, okay, so actually it can only apply to actual functions for it to be for it to have an inverse. So in other words, if I do like, I don't know, if I do some random line, and I know that this is f of x, well, if I do horizontal lines all over, I can see clearly that it only crosses it once. So therefore, f of x is 1-to-1 and has an inverse. So it's really the opposite of when a function is a function graphically. When we do the horizontal line test, that is for inverse functions. Now, if I go ahead and state the following, like, let's say f of x is equal to, I don't know, if I have, like, for example, some kind of parabola, they call this a parabola, like that, and I know that this is f of x, so I know that oh my god, I don't know why it keeps doing that. Oh. If I draw horizontal lines like this, because this is going on, it's crossing it twice. So f of x does not have a function. So there's one thing I do want to, f of x does not have an inverse. But there is one thing I want to emphasize, and this is going to come later. It is going to have an inverse, but it's going to be a restricted domain. I will go over that later, but in this case, this relation, in this, just talking about the graph itself, according to horizontal line test, it does not have an inverse. To HLT, according to HLT, I'm gonna just quit this. I don't know why it's being stupid. I'm sorry, guys. This is really irritating. Give me a second. Okay. Sorry, guys, hold on. According to HLT, horizontal line test, f of x is not 1-to-1 and does not have an inverse, according to just this. Okay, guys? Later, I am going to show y'all that it does, but it's going to have a restricted domain. But according to the actual definition of inverse functions by horizontal line test, it does not have an inverse. There is one more thing I want to go over in this chapter, in this section, and this is going to be it. So these are the type of parent functions we have. There is the constant function. A constant function is where it equals any kind of number. In this case, the graph is going to be y equals 2, f of x equals 2. So this is what we call a constant function. It is really a horizontal line about the y-axis. The identity function is really just the the linear function, the parent linear function, f of x equals x. This is considered a linear function, okay? So we want to remember that for calculus, and we just really want to go over, we want to remember all of these. So we can clearly see that, it is a linear function. There is another one, the absolute value function. This one is f of x equals absolute value of x. We've done these when we were in college algebra. So this one just means that, you're taking the absolute value of everything. When you do an absolute value of a negative, it's going to be the positive number, so on and so forth. It's really the distance from x, or from 0, excuse me. This is the quadratic function. So the parent quadratic function is f of x equals x squared. This is a parabola. Okay, this is what we call a parabola. And that's what I named. That's what I said earlier when I was doing with the parabola. I was stating that this curve represents a parabola, and it is called a quadratic function. So we can clearly see that that is how it looks. We want to make sure we understand how all of these look graphically. This is a cubic function. Both x squared and x cubed are polynomial functions. So, and also x is a polynomial function, but we'll go over that later. But yes, this is how x cubed looks. So you can kind of see how it's reflected about the origin. We'll go over that later. This is called a reciprocal function. We also call these rational functions, but this is the parent reciprocal function, 1 over x. It is where it is kind of like a fraction, where x is at the bottom. We can also say x minus a over x minus b, whatever, but I will go over that later. But this is how the parent function looks for 1 over x. Again, we want to make sure we understand how all of these look, because if we don't, then calculus is going to be very difficult. This is one that I always forget, and it's 1 over x squared. So we can kind of see that the left side of 1 over x has been reflected, and this now represents 1 over x cubed. So this is the reciprocal squared, okay? This is how it looks. And in calculus, you're going to actually do a problem where you can see how it's called Gabriel's horn, and you can kind of see the area from 0 to whatever number to 1 using, or from 1 to 2 using Gabriel's horn by using improper integrals. But that is a whole other thing in calculus. But this is kind of why we must understand how these look. These graphs are so important for Cal 2 as well as Cal 1. All of this stuff is important. The square root function, this is also called a radical function, where it has a root. So this is how it looks. We can clearly see it kind of looks like the x squared term about, when we're doing about y equals x, or I'm sorry, about the x-axis, or when it's reflected, but it has a restricted domain. So that's what I was talking about. But we'll go over that later. But this is how it looks. Okay, guys. This is the cubed root. So it kind of looks like the graph that's really like, when we do the inverse of y equals x cubed. Okay, guys, and that is how that looks. So now that is going to be the end of this section, guys. I am so sorry if it was so long. It did take me a while, but I really hope that helped. If anybody has any questions whatsoever, let me know. But that is going to be it for this first section of this section of this book. So if anybody has any questions, let me know. I will also I'm gonna go ahead and put a link to the book in the description. I don't know if I can edit it. Hopefully I can. If not, I'm gonna put the link. I'm gonna post a community post, and I'll put the link to the book in that post. But that is that is going to be it for this live stream, guys. Again, the book is from openxtax.org, Precalculus 2E. If you go over here, you're going to go to math, and it should be in there. It's Precalculus 2E. It looks like this. It's the blue, kind of blue textbook. But that is going to be it for this video, guys. Thank you so much for watching. If you did watch, or if you do watch, thank you so much. Again, if you have questions, or if anything is confusing, let me know. And with that being said, guys, please like, comment, and or subscribe. And thank you so much for watching, and I will see y'all next time. Bye, guys.